What existed before the Big Bang? This is perhaps the most profound question we can ask. It takes us to the very edge of our understanding, beyond the familiar world of stars, planets, and galaxies. We often think of before as a point in time, like yesterday came before today. But when we talk about the origin of the universe, this simple idea breaks down. The Big Bang wasn't an explosion in space. It was the beginning of space itself. It was also the beginning of time. So asking what came before is like asking what is north of the North Pole. The question itself might not make sense in the way we usually think. Our entire observable universe, everything we can see and touch and measure, began in an incredibly hot, dense state about 13.8 billion years ago. From that single point, it has been expanding and cooling ever since. This is the core idea of the Big Bang theory. It tells a remarkable story of cosmic evolution, from the first light to the formation of galaxies. But it starts at a specific moment. Before this moment, our current laws of physics simply do not apply. There was no ordinary matter, no light, no stars. There wasn't even an empty void waiting to be filled. There was simply no there and no then. So if time and space began with the Big Bang, the concept of a before becomes a paradox. It's a bit like trying to imagine a color you've never seen. Our language and our minds are built to work within the framework of time and space. Trying to look past that beginning is a tremendous challenge for science. It requires us to think in entirely new ways. Instead of a simple timeline, we might need to consider that our universe is just one part of a much larger, more complex reality. It's a frontier where physics meets philosophy and where our deepest questions about existence reside. This leads us to consider what nothing truly means. In our everyday lives, nothing means the absence of things. An empty room contains nothing but air. But in physics, especially at the quantum level, nothing is a very busy place. The quantum vacuum is not truly empty. It is a sea of fluctuating energy, where pairs of particles can pop into existence and disappear in an instant. Some theories propose that our entire universe could have emerged from such a quantum fluctuation, a random event in a timeless, spaceless nothing that was actually something. This idea challenges our intuition, but it is one of the paths scientists are exploring. Immediately after the Big Bang, the universe was a chaotic and unimaginably hot soup of energy. During the first fraction of a second, in an era known as the Planck epoch, the conditions were so extreme that our two great theories of the cosmos, general relativity and quantum mechanics, fail to describe it. We simply do not have the mathematical tools to understand what was happening. This is the current limit of our knowledge. We can run the clock back to a tiny fraction of a second after the Big Bang, but the instant of creation itself remains shrouded in mystery. We need a new theory, a theory of everything, to unlock that final secret. As the universe expanded and cooled, things began to change. Within the first millionth of a second, the fundamental forces of nature separated. The superhot energy started to condense into the first elementary particles. These were the basic building blocks of everything that would ever exist. Quarks and leptons, including electrons, appeared. For a brief time, the universe was a dense, swirling plasma of these particles. They were moving at nearly the speed of light, constantly colliding with one another. There were no atoms yet, not even protons or neutrons. It was a primordial state of pure potential. After a few microseconds, the universe had cooled enough for quarks to bind together. They formed the protons and neutrons that make up the nuclei of atoms today. For every billion particles of antimatter, there was about 1,000,000,001 particles of matter. This tiny imbalance was crucial. As matter and antimatter met, they annihilated each other in flashes of energy. Because of that slight excess of matter, something was left over. That remnant is what makes up you, me, the Earth, and all the stars in the sky. We are here because of a tiny asymmetry at the dawn of time. For about 380,000 years, the universe remained a foggy, opaque plasma. Light could not travel far before being scattered by free electrons. But as the universe continued to cool, protons and electrons finally combined to form the first stable atoms, mostly hydrogen and helium. At this moment, the universe suddenly became transparent. Light was set free to travel across space for the first time. This ancient light is still visible today as the cosmic microwave background radiation. It is the afterglow of creation, a faint echo of the Big Bang that we can still detect with our telescopes, giving us a baby picture of the cosmos. While the Big Bang theory describes how our universe began, it does not rule out the possibility that it wasn't the absolute beginning. Some scientists explore more speculative ideas, pushing the boundaries of what we can know. One fascinating concept is that our universe is not the first. It could be just one in a long, perhaps infinite series of universes. This is the idea of a cyclical universe. In this model, the universe undergoes endless cycles of expansion and contraction. It begins with a Big Bang, expands for billions of years, and then perhaps collapses back on itself in a big crunch, leading to a new Big Bang. Another way to think about cycles comes from the brilliant physicist Sir Roger Penrose. His theory is called conformal cyclic cosmology. Penrose suggests something truly mind-bending. He proposes that our universe will expand until it becomes cold, dark, and empty. After an almost unimaginable amount of time, when all matter has decayed and only stray photons remain, something remarkable happens. In this vastly empty future, the concepts of time and distance lose their meaning. The universe, having lost all scale, becomes mathematically similar to the hot, dense state of the Big Bang. According to Penrose, the end of one universe can therefore become the beginning of the next. The vast, empty future of one cosmic eon becomes the Big Bang of another. It's a grand and elegant vision of cosmic rebirth. What we call our Big Bang might have been the final state of a previous universe. Penrose even suggests that we might be able to see faint traces of the eon before ours. He believes that events like supermassive black hole collisions in the previous universe could have left faint patterns or Hawking points imprinted on the cosmic microwave background radiation of our own universe. This is, of course, a deeply theoretical idea, and many physicists are still debating the evidence. But it offers a compelling alternative to a single, one-off creation event. It suggests that the cosmos has no ultimate beginning and no final end, but exists in a state of eternal transformation. It redefines our place in the grand scheme of things. We wouldn't be inhabitants of the one and only universe, but just one chapter in an infinite cosmic storybook. It's a humbling thought that connects our distant future back to our most remote past, in a cycle that could continue forever. But beyond cycles, there is another idea that is just as staggering: the multiverse. This theory suggests that our universe is not alone. Instead, it might be just one bubble in a vast cosmic ocean of other universes. Each of these universes could have its own unique laws of physics. Some might be similar to ours, while others could be completely alien and inhospitable to life. In this multiverse, Big Bangs could be happening all the time, constantly creating new universes. Our beginning would then be just one of many, a local event in a much larger cosmic landscape. These ideas, the cyclical universe and the multiverse, are at the very edge of theoretical physics. They emerge from our attempts to unify quantum mechanics and general relativity, and to understand phenomena like cosmic inflation. They are not wild guesses, but are based on sophisticated mathematics. However, they are incredibly difficult, perhaps even impossible, to test directly. How could we ever hope to see another universe? How could we prove that ours came from a previous one? These are immense challenges that scientists are working on, but for now they remain beautiful and tantalizing possibilities. The search for what came before the Big Bang pushes science to its absolute limits. It forces us to confront the nature of time, space, and existence itself. We have a powerful and successful theory in the Big Bang, which explains the universe from a fraction of a second after its birth until today. But that first moment, and the question of what set it all in motion, remains a blank page in our story. It is a reminder that no matter how much we learn, there is always more to discover. The universe is far more strange and wonderful than we can possibly imagine. Ultimately, we do not know for sure what came before the Big Bang, or if asking before even makes sense. Was it an eternal cycle of cosmic death and rebirth? Was it a quantum fluctuation in an eternal vacuum? Or was it just one of many beginnings in an infinite multiverse? These questions represent one of the greatest remaining mysteries in all of science. It is a grand puzzle that drives our curiosity and inspires us to keep looking up at the stars, wondering about our origins and our place in the cosmos. The quest for this answer is a journey that has only just begun.